In summer 2020, I compared the Leica M10-R with the Leica SL2 and paid in particular attention to recovery out of shadows and highlights, and the M10-R seemed to be superior when it came to the recovery of the structure of clouds in an overblown sky. In this video, I'm returning to that topic, want to look in greater detail into dynamic range of the Leica SL2, recovery out of shadows and highlights, and provide more data points on that topic. Let's kick off the video. My second round of testing dynamic range of the Leica SL2 sensor was shot with the standard zoom from Sigma 40L mount system here, 24 to 70 millimeters, constant aperture f2.8, but that didn't play a role for my shooting here. And the reason why I use this lens and not one of the standard, let's say, aposummicron lenses or Summilux lenses in the Leica SL lens system is because I was shooting with that lens in order to test it out. And there will be in the next couple of weeks a video where I share my impressions how it was shooting with that lens on the Leica SL2 body. And I had this lens with me, so I just did the dynamic range test with that lens. It doesn't discount the results, of course, because the dynamic range is a property of the sensor. And I'm going into details in a moment. In terms of shooting parameters, the only thing I want to mention here, because we see this later in post, is that I went for an aperture of f13, and the reason was that I wanted to have the largest depth of field, so sharp corner to corner from my position up to the far horizon. But clearly at f13 you have a tiny little bit of risk that there is some diffraction kicking in, but this is not about sharpness in general. It's more about recovery out of highlights and shadows. That's why I thought this will not discount in any way my results and impressions. And in terms of getting the work done, I went into the camera menu and decided for exposure bracketing. And you see I decided here for 5 frames. And the EV steps in both directions were 2 stops. So you see this on the pattern here. So I start with the correctly exposed image, and then I go 2 stops, 4 stops towards underexposure and 2 stops, 4 stops towards overexposure. In this way, the camera got done the work for me and I just had to look at the images in post. I'm now here in Lightroom and did an import of the 5 images from that bracketing. And number 3 here is the correctly exposed image. And then you can basically look into the metadata because this was a bracketing shooting. It shows you the so-called exposure bias and says 0 EVs. So that's basically my midpoint. Then going to the left-hand side to image number 2, you see this is 2 EVs, means 2 stops into underexposure. And then the next one is actually 4 EVs, means 4 stops towards underexposure. And then on the right-hand side, we have image number 4. That's 2 EVs or 2 stops up. And then the number 5 here is 4 stops up. And what we are going to do now is, first of all, I want to make this image a little nicer, but not by doing some sophisticated post-processing. I just push the auto button, which will make the image a bit more bright. And then I go back into the library. And then what I'm going to do is, I'm basically selecting them all here, go into help in the menu bar and type in exposure. And then it gives me immediately here, develop settings, match total exposure. And when we do that, we see that we now have matched image number 1, 2, 4, and 5 in the best possible options of Lightroom with the exposure of number 3. Looking at these images from a distance, number 1, 2, so 4 stops down, 2 stops down, correctly exposed is a reference point, then 2 stops up. That all didn't create any problems in recovery. And these images actually look really good. Number 5 is the exception. That was 4 stops overexposed, and here Lightroom was no longer able in post-processing to recover the structure of the sky out of the highlights and the overblown exposures. So let's for a moment look at image number 5 here, and let me go to the develop section in Lightroom. And let's take back the exposure matching for a moment. So this was the image as I got it out of camera, totally overblown. And clearly if we match this, we can recover a lot out of the overblown exposures. And I think maybe I put them side by side. So this is the version before post, this is after post. And if you look here, for instance, into that farmhouse where it's coming from, That car here, because of its white color, is hardly recognizable. If we do the post-processing, it recovers everything here nicely out of the overblown exposures and highlights. But for the sky, every help came too late. And let me switch back to the full image here. And you can basically see this if we reset this on the histogram, which is super skewed to the right-hand side. And then something occurs which people call clipping. And if in the clipping effect, the pure white is basically what is dominating, like we see it here on the sky. I can actually also make this visible here in Lightroom. Then the information is lost and cannot be recovered. And that's what happened in this image. So no structure of the sky, of the clouds. That's not possible to get it out of these overblown highlights here. And that is basically occurring at 4 stops up. At 2 stops up, it actually looks pretty nice. And if we just make this big, the structure of the clouds is completely recovered, and 2 stops were not a problem at all to get everything back. And we look into these images in detail in a moment. So going back to the overview here with the 5 thumbnails, on the underexposed images, we could actually easily go for -2 stops and for -4 stops. And as I said, I put them side by side with the reference image in a moment. But here we see everything could be nicely recovered. And there is a technical reason why it is easier to recover out of shadows than to recover information out of overblown highlights. In order to understand this better and without going into too much detail, Leica is advertising the SL2 as enormous dynamic range and a color depth of 14 bits per RGB channel. So let's quickly consider what that really means. And clearly I'll do this in an illustrative, non-scientific manner here. First of all, 14-bit RAW means 2 to the power of 14 values per RGB channel. So that means we have 16,384 values, but since in the binary system the 0 is counting, we have actually numbers 0, 1, 2, 3, and so on, up to 16,383, which is 2 to the power of 14 minus 1. In a simplified way, we could say that each bit here, so 14 bits, each of that 14 bits represents 1 EV or 1 stop. And that in turn means 14 stops of dynamic range. So if we would have only 1 bit, then we would have 2 values at disposal, which is 0 and 1. If we would have 2 bits, we would have 4 values at disposal, which is 0, 1, 2, and 3. And if we would have 3 bits, we would have 8 values, which is 0, 1, 2, 3, 4, 5, 6, 7. At the very left-hand side of that spectrum, we have 0, which represents the pure black. And on the very right-hand side, we have 2 to the power of 14 minus 1, which is 16,383, and clearly now represents a pure white. Now, what does it mean to have 2 stops down? And on the very right-hand side here, you see the original image correctly exposed with 1/8 seconds as exposure time. And that's our correct exposure. If I go 2 stops down, I end up at an exposure time of 1/30 seconds. And that means I have to be 2 times and another 2 times faster than what I had on the 1/8 seconds. And if we do that math quickly, we have 1/8, 2 times faster is 1/16, 2 times faster is 1/32, and then rounded of course to the next stop, which we have here is 1/30 seconds. On the most underexposed image, we then have 1/125 seconds, and that's 4 stops away from 1/8 seconds and 2 stops away from 1/30 seconds. And again, quickly doing the math, 1/30, 2 times faster is 1/60, another 2 times faster is 1/120, and then rounded to the next stops is 1/125 seconds. Of course, the same principle applies in the other direction. Accidentally here, I placed the 2 stops and 4 stops up at the left-hand side of the correctly exposed image, but the math is working in exactly the same way. 1/8 seconds is the correct exposure. 2 stops up is 1/4, 1/2 seconds, which is 0.5 seconds. That's the metadata in the middle. And then another 2 stops up from 0.5 seconds is 1 second, 2 seconds. So on the very left-hand side, we have a 2-second exposure. Now, in order to understand what's coming next in my chain of arguments is that the human eye works completely different than a camera sensor. And the best way to understand it is to make an example. So imagine a very dark room and someone sitting and writing on a manuscript just enlightened by a candle. And then the human eye with its pupil will adapt to the environmental light and will open the pupil so that the perception of light and light intensity is much stronger than suggested by a single candle. If you enlight 2 candles, you have, all things being equal, the double amount of light. But the human eye will not perceive it as the double amount of light, but as an incremental increase of light intensity. In other words, that means that the human eye's perception of light intensity is non-linear. And that can be best illustrated by a chart like the one you see in front of you. It's approximate logarithmic, and it means the following. On the left-hand side part, if on the x-axis is the amount of light, it doesn't take a lot to let the human eye think that the room is bright. It sometimes is sufficient to have a candle, and then the pupil of the eye will adapt. Let's say the eye opens its aperture, and the perception of light might already be very strong. On the right-hand side, you see illustratively a saturation effect of that curve. And that means if the environment is super bright already, and even if you add a lot of more light sources, the human eye will close its aperture, means closing the pupil, and the perception of light will again not be as if these light sources which were added were truly additive to the already bright environment. In contrast to the human eye, camera raw and the camera sensor is linear, so if the double amount of light hits the sensor, it will release the double number of electrons on the sensor. And that is a true linear relationship, fully in contrast to the perception of the human eye. If we now return to our 14 EVs or 14 stops dynamic range, which are illustrated here at the top of the chart in front of you, then we have to acknowledge that the camera sensor is linear in a way that the double amount of light intensity will release the double number of electrons. And in order to depict this, I did draw at the bottom of the chart the range of available raw values, which is from 0 to 16,383, so 16,384 values. And then, since we have linearity on the camera sensor, 8,192 is the exact midpoint of that range. But if we now map the EVs or the stops to that raw value range, we find that the stop with the highest light intensity at the very right hand side of the upper part of that chart makes up 50% of my raw value range. In other words, coming from the right hand side of my value range, 50% of granularity and values are taken up by just one stop. And based on what I explained, it should be immediately clear that this picture will not change if I go down from 14-bit to 12-bit or 10-bit. It will always be the case that the right-hand side 50% will be assigned to one stop only. And the conclusion of this is pretty obvious. That means if you climb up from 10-bit to 12-bit or from 12-bit to 14-bit or whatever you have, if you increase the bit, you will gain more granularity at the left-hand side, which is in the shadows, and more differentiation of tonality in the shadows than you will get in the highlights. So this should explain by now why -4 stops underexposure is less a problem than 4 stops overexposure. And clearly I simplified the technicalities here a lot, but I hope it was useful to better understand what's going on here. I will now return to the sample images, but at the end of the video I will make a few remarks and recommendations how you can leverage that know-how I now provided for your own shooting with the Leica SL2, but also for other cameras, of course. So clearly we want now put these images side by side and also crop or zoom into the images to see better what they are made of. So let's pick the one with -4 EVs and the reference image first. Let's put them side by side. And on the left hand side we have now -4 EVs and then exposure matched with the reference image here. And if I zoom into these images, you actually see that your shadow recovery comes with a bit of noise here. That can be fixed with the luminance slider to some extent in Lightroom and is not a big problem, given that you're underexposed by 4 stops, but it's something you need to know. The more you have shadowish areas in your image, the more you need to recover out of the dark, the more noise you will get in the image. But in general, it's nevertheless a good image. And on the sky, you see the noise a little bit, but not too much. Again, if we play with the histogram, we could make these areas visible and could have a look at that. But that's not what we are going to do now, because that will make this video here unnecessarily long. Another difference besides the enhanced level of noise on the left-hand side is the coloring here, but that's very likely due to the fact that on the reference image I use the auto post-processing button in Lightroom, and we can quickly check that. So if I go back into the grid view here, I take the reference image, I go into develop. I notice that on exposure we have 0.40 increase. I reset this and just do the exposure here. Then very likely if we go back and put it now side by side with the -4 EV image, let's do this in this way here. Then the coloring is a little more equal now. It's still more saturated here on the right hand side in the reference image, but is, you know, close to what we would expect. So let's now quickly compare the -2 EV image with the reference image. Let's put them side by side, and there is no visible difference here. These images are absolutely the same. Let's zoom in. We also see hardly any more noise here on the image where we recovered out of the shadows. So -2 stops down is absolutely no problem for that camera, and that is consistent with my video some weeks ago when I compared the M10R with the Leica SL2. Comparing the image with +2 stops with the reference image, putting them side by side, let's check again. So here we have 0 EV, here we have +2 EV on the left hand side. There is hardly any difference recognizable here. These images are pretty much the same. And that is something a lot of people asked me on my comparison video between the Leica M10R and the Leica SL2, whether I went again into that topic where the Leica SL2 image could not be recovered fully out of highlights. And here with 2 stops is absolutely no problem. You see the structure of the sky is exactly the same. And also the details we have in that image, they are exactly the same. The coloring is the same. And by using this exposure matching tool in Lightroom, we can compare them and can make them looking exactly the same. On image number 5, we already spent enough time, I think, but I want to put it side by side with the reference image and to show again how it looks in the parts where we actually could nicely recover and where we did not lose any information due to overblown exposure. So if I select my reference image here and select this one here and we do an exposure matching, then we get back what we saw before some minutes ago. And now let's put them side by side. So image number 5, image number 3, side by side. And you see on the parts where we actually could recover because we had no clipping effect, it's a pretty good result given that the left-hand side is 4 full stops up. And if we zoom in here and look into this in detail, we see differences in the coloring and saturation that can be recovered by means of post. But the details we get out of these overblown exposures is really fascinating, I think, and shows the strong dynamic range even towards the highlights and towards overexposure of the Leica SL2 sensor. I'm going to conclude now. First of all, underexposing by 4 stops is not a problem at all. You can recover nicely out of dark parts of the image, and the dynamic range of the camera is very strong. It will come at the expense of some noise, but you can correct for this in post. Going up by at least 2 stops also is not a problem. We could nicely recover everything out of that overblown image, and probably 3 stops will also be fine. I'm second guessing here. 4 stops will kill structure in overblown areas, as we saw on image number 5, and that happens for the reasons I outlined in the video. I also explained why the 14-bit raw depth is more helping you on the shadows and the dark parts of the image than it's helping you on the overblown parts of an image. And I hope that explanation was helpful. And of course, we can leverage this now to our advantage. What we learned is that up to 4 stops down towards underexposure is not a problem. We can recover out of shadows nicely. And if we go up by 2 to 3 stops, we also have not a problem because we also can recover out of highlights. So here's an example where I went up with EVs in order to get more light into the foreground consisting here of trees and bushes. And since I know that I can recover structure out of highlights, I can afford to go up by 1 or 2 EVs in order to make the foreground brighter. Here is the opposite situation. Here I exposed to the left and went down in EVs to get the full structure and the full coloring of that sunny sky. And then of course my foreground will be very dark and I will lose structure in the shadows, which I know now I can recover even if I would go down by 4 EVs. I don't think that shooting to the left or shooting to the right is a universal concept. I think it should be applied situatively and where it makes sense. Here, by the way, is, I think, the best way to deal with very different light situations in one frame. Just go for the bracketing, which I demonstrated on the Leica SL2 camera menu at the beginning, and compose the different frames from the bracketing into one HDR image. I hope this video was helpful and is appropriately addressing the questions I got in the comments after I posted my video on my comparison of the Leica SL2 with the Leica M10-R. If you liked it, don't forget to drop me a thumbs up and don't forget to stay tuned on my channel. Thanks for watching, stay safe and healthy, and peace out.